Thank you, Stephanie. So welcome everyone, and thank you for taking some time to attend today's webinar, part of our AC series. So if you're looking for more information on the other webinars, you can simply log on to our website to access them. So all right, today we'll be looking at the importance of connecting the structural engineering model to Revit in order to have a true BIM workflow, and obviously taking a look at the advantages of such a workflow. So housekeeping items maybe before we start. All attendees are muted, but obviously we encourage you send your questions and to do that through the GoToWebinar chat. So what we'll do is after today's webinar, we'll send everyone a PDF document with the answers to these questions. Like always, the webinar will also be on our YouTube channel afterwards. So today's agenda, before going into the software and demonstrating how we can achieve a connected workflow and then taking it a step further by reusing all the data-rich information in Revit, I want to quickly go over who is GreatTech, what we do, and what brought us here to discuss today's topic. Secondly, we all know or at least have an idea of what BIM is. However, most companies today, having adopted 3D software, are now pushing to level 2 BIM, leveraging the eye, the information. So kind of take a look at that and what level 2 BIM is. We'll then look more closely at how to reutilize this intelligence directly in Revit. We'll also take a quick look at the challenges structural engineers and designers face every day when not using a BIM workflow. And finally, we'll go in depth in the software with our simulated cases. Okay, so who is GreatTech? What do we do? Well, in the AC world, for more than 30 years, our focus has been with structures, and we strive to be the leading BIM structural specialist. So basically, we have two hats. We are the third biggest Autodesk reseller worldwide. And our second hat, we create our own software and add-ons, which of course are interoperable with Autodesk software. We are a global company with more than 30 offices in more than 15 countries. And we've acquired throughout the time, obviously, many companies like Robobot, which is in Poland, who were the original makers of Robot, which is now owned by Autodesk. And we also sold some technology to Autodesk, like the steel detailing software, Advanced Steel. So we really understand how to build software that can synchronize together. For example, Autodesk Revit, Advanced Steel, and our own analysis and design software that we'll be demonstrating today share the same databases. So that's very, very important. We have a big international team of close to 100 developers, but we also have local North American teams who develop, support, and localize our software for the US market. That's extremely important to stress. We have 4 engineers, and we guarantee, that are part of our tech support team, and we guarantee a response within 4 hours. So that in essence brings us to discuss BIM. Like I previously mentioned, companies are moving to level 2 BIM, which is distinguished by collaborative working. All parties use their own 3D CAD models, but not necessarily working on a single shared model. The collaboration comes in the form of how the information is exchanged between different parties, and that's the crucial aspect of this level. So previously, the BIM winners, if we can say, were the owners and managers of projects. Certainly many actors take advantage of it, but I'm talking about a measurable gain in value, if you will. Currently, we are witnessing this transfer of hands, if you will, regarding the BIM value, because firms in pre-construction need to justify setting up a BIM organization and using BIM compatible software. It costs time, it costs money, resources, so they need to attach a value to it. They need a return on investment. Businesses no longer simply want to get a BIM file at the end of their mandate. They're looking to implement real BIM workflows, and that is the information which is key. So we'll take a look at that. So structural engineering, it's not yet BIM. When looking at the construction cycle in a BIM process. There are obviously several steps, but if you look more closely at the design and the analysis steps, if you were to zoom there, you'd see there's a break with the structural engineering model and Revit. There's no real synchronization. Some folks are doing some imports, some exports, but you look at mechanical, like electrical, HVAC, etc. All these industries are already synchronizing with Revit, but the structural engineering world is late to the party. The structural engineering model is probably the model with the most data-rich information, and it's not being used for many reasons. Either there is a lack of knowledge on how to do so, some technological barriers, bad past experiences, which in turn create distrust or of results, etc. So it is, however, possible, and we'll show you how it can truly be effective. So if we look at today's traditional workflow, you can see that engineers are using analysis and design software, are maybe using Revit or using Revit files, AutoCAD, and Excel and HandCalc, so different tools, and they're generating a lot of material, a lot of information for reports, for drawings, some Revit models, some AutoCAD models, some other 3D models. And on the other hand, the designers have to take all of this information and bring it back down to a Revit model, or maybe still today in some cases some AutoCAD drawings. So it's really not an ideal world, a BIM world. There's a lot of possible errors that can happen. There's no collaborative work in this kind of scenario. So if we kind of summarize the challenges that engineers face today with these, they have multiple software solutions. So some are model-based, some are tabular. It's really an inconsistent BIM output. There are 2D digital documentation that is being shared. So design reports and associated documentations, that's not BIM. It's really a disjointed workflow, and it's really repetitive. So you waste time and you increase the chances for human errors. And there's no usage or reusage of BIM data. So those are the main challenges engineers or structural engineers today are facing. And if we look at the industry challenges for the designer, well, you'll see that the BIM software being used, mostly Revit, well, it's only good for generic geometry, because a lot of the analysis and design software currently are only sending the geometry and some intelligence, but they're not sending what we can send with our software, like the loads, the results, the design assumptions. So they're basically have to redraw, or if they're lucky, they get to have basic geometry, not more than that. If we're looking at the reinforcement, concrete reinforcement needs, well, they'll have a challenge there because they don't have access to the engineering data that's in the analysis and design software. So they have to go to another software to do that. Those drawings, that engineering data is in probably in AutoCAD or in a 2D format, so that makes the whole process much more long. It's really not BIM, and those software that we're talking about, those detailing software, are probably most often 2D. A lot of it is still done in AutoCAD, so it's really disconnected from the BIM process. So if we're looking at what we want to attain, where we want to go, as an industry, and what Greatech can offer, is bringing that next generation structural BIM technology. So one that can connect the BIM workflow, so we can trust it and there's no loss of information. We're not talking about import or export. We're talking about synchronization. Actually, we've been synchronizing for a while now. We're even talking about going to the next step, reutilizing that data for reinforced concrete, for example, or for other processes we'll see. So transferring that intelligent information, not just geometry, but like I said, loads, design assumptions, results, etc., and using that to calculate, for example, reinforced concrete, producing automatic drawings and being able to manage revisions automatically. So this is what we want. It's a connected BIM workflow. So for example, we'll start in a Revit model. We'll be able to send it to our analysis and design software. So in this case, Greatex Advanced Design. We'll be able to do add our loads, our analysis, and run our design. When we're happy, we're able to send all that information. So again, that intelligence, that geometry, that those loads, even the design results, design assumptions back into Revit. And using that analytical model that's available in Revit, we'll have all those results and we'll be able to use and realize them. So Mike will show us just in a few seconds with another technology, the BIM designers for reinforced concrete, how we can do that directly on Revit, also available directly on Advanced Design. So with that, I will hand it over to Mike, and we'll go ahead and see our 3 simulated cases.
Thank you, Sebastian. As Sebastian had mentioned, there are several industry challenges facing rebar placement in a BIM workflow. And we're going to highlight some of these challenges in our webinar today. The first one being incorporating an engineering model. These models are often filled with rich information and a lot of intelligence, such as the rebar placement and the design. A lot of times this is neglected or not done, and we're going to show you some reasons why this may be a favorable case for some people. And so when we're creating rebar in 3D, oftentimes the engineer needs to go in and do his design. From there, he may hand the technician or the drafter a 2D representation of the rebar. This can be done in DXF or in AutoCAD. This could even be something as rudimentary as hand sketches. But once that's complete, what happens is the technician needs to go in and redraw this in Revit. So the first thing that needs to be done is the Revit model needs to be created in 3D. Sometimes this is happening before or during the engineering process. With this, we will be able to create our sections. We create column sections, foundations, and these are represented often as families in Revit. With these section definitions, we will create elevation views. From the elevation views, we'll be able to place rebar, as you can see highlighted in yellow here. We're placing the rebar. And from the 2D views, the rebar is placed. And you could add your annotations and dimensions as you'd like. As well as, once this is complete, we can see the rebar in a 3D cage, in a 3D view. But the 3D only happens by a 2D placement. With these 2Ds view cuts, we can add them to a sheet and create our drawings. So this process is often long and tedious. What we can do is we could automatically place the rebar based on a structural process. The engineer will be able to put 3D rebar cages just based on his analysis from a finite element software. And we're going to see this in a small video following this. From this, we can create engineering reports to validate the calculations that have been done, ensuring that the rebar is placed to code. Now, this is based on localization. So US codes for ACI are also incorporated here. With that data that we have, we can create rebar schedules and material schedules that go along with it. And we could automate or automatically create 2D views and drawings, placing those 2D views on a drawing. Let's have a look at a short presentation how this can be done. In this presentation, we'll look at the relationship between a finite element solution, advanced design, and Revit. So we'll start off with our Revit structure created here. We could see the 3D model as we had created it, and we could see simple Revit families, some L-shaped concrete elements, some steel-shaped wide flange sections, and some square-shaped concrete columns as well. We have different families that are also represented by the foundations here, some on pedestal, some that are hollow. And if we have a look here, we can see that the slab has a slight overhang. Now, it's very important to know that a lot of information can be transferred using the analytical model. So if the analytical model is well presented, as we can see here, though there is overhang in our slab, it is lined up properly with our columns. So the analytical model has a lot of bearing on what happens with the engineering model as well. So we're going to just look at this analytical model all by himself without the 3D model beneath it. And you can see that there's no overhang, and we also have some supports at the base. These will be exported as foundations as well. And we can see the alignment is well placed and everything has been tidied up in our analytical model. This ensures that the engineering model will be imported properly. With our Graytech Power Pack, we have a direct link with an advanced design. This is a finite elements solution, and it also depicts the export, how many elements were done, and it gives you some representation on what was exported in the structural elements. We're going to ensure that the structural materials are imported also. So those are the mapping of the materials, and here we're creating our custom sections that have imported directly from Revit as well. So here we have our 3D model. We're going to open it fully, and we're going to look at the cross sections to ensure that they're properly imported. So we could see the same L shapes in those corners, those same square shapes, the same steel shapes had also been imported with the proper materials as well. And we could see that that analytical model being tidied up and being cleaned up has done us well. Everything is aligned and the engineer has nothing to worry about here. We could obviously start doing our project and start inputting forces on our floors to make sure that we're doing a proper design. And so this would be the part where the engineer is taking in these forces and deciding what he wants to put in. He'll also define things such as end conditions, and we could see the representation physically on our advanced design model. So we could place those forces on our structure, and we could create our different load cases as an engineer would do. We could also automatically generate wind, and that's what we were showing here. And we could create our load combinations as well. Once the load combinations are complete, we'll save the model and we'll launch our analysis to have our finite element calculations happen. There's some information that's depicted in the command line letting us know of any warnings or any possibilities that can need to be fixed. So we could see the finite element mesh that has been created. We could play with this mesh as an engineer would do, ensuring to get the proper calculation. Here we're going to demonstrate some results, some deflections that can be viewed. We could also see bending moments and shear diagrams. And we're going to ensure that we're exporting the right results. We're going to export the forces on the linear elements. And we're going to do this with our Graytech BIM, our GTC file, and we're going to export that to synchronize it in Revit. So we're just going to give it a name here, and we're going to save it. This is when we go back into Revit to synchronize that model. Now the synchronizing of the elements is not going to just be the elements that have changed structurally. We're going to synchronize such things as forces, as internal forces, as load combinations, and we could see those green elements in the base of our spreadsheet are depicting forces that had been added. If there would have been things deleted, we would have also been aware and seen that graphically on our screen. We had mentioned that it's also internal forces will be exported, and we could see the forces that had been imported on our analytical model. Some of you may already know that Revit has some certain capabilities in this regard, in that it could hold certain engineering data. We could see that those load cases that we created in advanced design had been imported also, along with those load combinations, and we're going to see them here. We could also visualize analysis results, and we're going to visualize such things as reactions at the base or reactions at the supports. These reactions are obviously going to be used for the placement of rebar in our foundations. So we could see them here and our base, the vertical reactions. We could also show bending moment reactions on our supports as well. And these are obviously, like I mentioned, information that the engineer will be using for rebar placement in Revit. And then we could also see bending moments in our beams. Once again, things that would be important for an engineer to display or to know when he's designing his structural elements. So we're going to go back into our 3D model. We're going to define and we're going to define and decide what assumptions need to be done for our engineering model. We're going to say, we're going to make sure that the load cases are there. We could see that the load cases are not there, so we're going to make sure that we import them properly. So we're going to go in and say that we want to import the analysis results from what was saved on Revit. So we can see import FEM results from Revit, and it's telling us that we made some changes to our model as well. And we're going to be able to see those results in our internal forces here, axial bending moments in our structure. With that, we'll be able to create our combinations as well to make sure that the design is properly done. This is based on your localization, and we could hit calculate. The calculation will demonstrate some things as diagrams and as well as reports for the engineer to ensure. And we had seen that in our PowerPoint presentation. And these are real 3D rebar elements in Revit. And we could do the same thing for our beams as well. And we could see that we have a 2-span beam here with transversal and longitudinal reinforcement that was placed. This was all designed and placed based on engineering assumptions as well as internal forces that the engineer had taken in from his analysis. And we could see the report that's being displayed here with some information that an engineer may ensure that the calculation has been done well. The next industry challenge presents itself in the form of a collaboration between other industries when using the engineering model information. What does this mean? What happens is certain times there may be changes that need to be done. Often can become from a collaboration with other disciplines such as MEP or HVAC systems. In which case, the engineer needs to go back, re-evaluate his possibilities or maybe his rebar placement, send the information back to the technician to change the rebar placement, and then we could recreate our drawings. Obviously, the recreation of the drawings is done automatically in Revit, but the placement in rebar is not. Let's see what this means using the reinforced concrete BIM designers on Revit. With that same beam that we just did our design on, we're gonna force some changes that need to be done. In here, we could put in some openings. We're going to make sure first that we're recycling and reusing the internal forces that had been taken in from the analysis model previously, which we can see here on our 2 different spans. This is a 2-span beam, so our first span and our second span are displayed here. And these internal forces were taken from our finite element analysis solution. So we could go into our geometry and we could create an opening directly on our member using the local axes. So we'll put in specific dimensions for our opening. Using the diagrams here, we could create circular or rectangular openings, and we're going to put in the length and the height of our opening. We'll be able to see it here on our second span. And we're going to zoom in a little here. What's important to know is that there is still a clash between those rebars. Because we generated the rebar before creating the opening, we're simulating that an MEP or HVAC duct needs to be changed or needs to be added into this section here. So what we would need to do is tell the engineer and have him reevaluate the rebar placement. But what we can do is have this recalculate, and the engineer could validate the calculations from the report created as we had seen previously. So we'll give it a second, and you'll see the rebar will be placed around the opening, and it will be all to code. We have our stirrups, our transverse rebar above and below, and we have the additional rebar going around the section opening. The last industry challenge comes from the ideology that better predictability will discover and solve potential conflicts earlier. This can't be more true. A 3D BIM model is not only for the end user or the client, but also to help find potential problems or potential conflicts early. This could be such a case when we're looking at a conflict between rebar and anchor bolts, for instance. If we could design and model these aspects together in one BIM workflow, we'll be able to see and discover potential problems before we get on site. When we get on site, these changes are often time consuming and costly and take a lot to fix. So let's have a look at what this means in a BIM workflow with the reinforced concrete BIM designers. Using the existing model we've been working on presently, we're going to just limit our view to the base level here. We're going to isolate our view to look at just this foundation. This is an isolated footing with a pedestal. We're going to input a base plate. The base plate will be visible in 3D along with the anchor bolts, as we can see here. Once we launch our calculation for our concrete element, we'll be able to see the rebar in 3D. This will give us a view and ensure we could verify if there is a conflict between several elements. So we're launching the calculation here. We're going to get the 3D rebar cage, and we're going to get the rebar in the pedestal as well. We could see those link anchors, those link rebars that are conflicting with the pedestal anchors. This allows us to catch these problems early before we go on site. If each one of these was done in a different software, the steel technical drafter may not catch the conflict, or the rebar drafter may not catch the conflict if the anchor bolts are not in their softwares. So what we're going to do is we're going to do a change to our geometry here. We're going to increase that pedestal to 800 millimeters, and we're going to relaunch that calculation, ensuring that we're using the engineering data that we had taken from our finite element analysis. Some of you may know the process it takes to reproducing or recreating a family element. You need to duplicate it and make sure that it's you punch in the right dimensions. So in using the BIM designers, we could easily also modify the rebar. It's not a one-time generation. We could also consult in dialog box format with graphics to make sure that the rebar that we placed is what we want. And then we could do whatever modifications we want to this rebar. So we could easily consult dialog boxes to make sure it's what we'd like. Once the rebar is created for these elements, we could verify any potential conflict once again by creating 2D drawings. This is an added value. Since we had created the rebar in a 3D cage, we could click the generate drawings and we could see the drawing is created here along with a plan view, 2 transversal cuts, and a cut also for the pedestal. Here we have the bar schedule that can be customized to your liking. We have our dimensions here and the rebar that goes along with it. So with one single click, I could create my 2D views without having to create 2D cuts. So we're going to do the same process with our beam here. So we're going to click generate drawing. We're going to see a sheet that adds itself with several cuts that follow along with it. So this is our S2 sheet. We could see an elevation view here. We're going to zoom in on this sheet that we can see here. And we could see the elevation view along with that opening that we had created. And then we have some transversal cuts to see in there. We have our bar schedule once again that can be customized. We could create our own personalized title header as we'd like. And finally, just to see the last part of the project where we had started from was that concrete column. So we'll come around full circle and finish off by displaying the drawings for the concrete column. An elevation view and some transversal cuts for that L shape showing the stirrups, transversal rebar, as well as longitudinal rebar.
All right, thank you, Mike. Great work. Very interesting stuff. So thanks everyone again. To conclude, well, GreatTech is your structural BIM partner. So I want to make sure to let you off by saying all the questions that were sent in will be answered, and we'll make sure everybody gets a copy of our answers. We also will be sending free web trials, so you folks can be able to test the software, and you also have access to our team's our tech support team. And we'll be running a sales promotion until December 30th, so you guys can take advantage of that. So you can see on the screen, if you're looking for more information, you can visit our website or even contact myself, Sebastian, for either sales or technical questions. Thank you so much, guys. Have a great day.